Hi, we are from Group 4. In this video, we want to present our mechatronic project, which is about hydroponic plant system. Let me introduce first. Hydroponic is a method of cultivating plant using mineral nutrient solution in water rather than traditional soil. This technique promotes plant growth by providing essential nourishment directly through the water, resulting in a faster growth, higher yield, and efficient use of water and space. It also reduces reliance on pesticide and herbicide, making it a sustainable and environmentally friendly option for food production, especially in urban areas with limited agriculture space. Dripping technique is the watering method. Deliver water and nutrient directly to the plant root through a network pipe, tubing, and emitter. This technique involves slow, precise delivery of water in small quantity, ensuring that plant receive the exact amount of moisture they need to thrive without wasting water. It can reduce water wastage as it delivers directly to root zone and minimize evaporation. The process also can allowing the nutrient to the plant and get healthier growth.
So as for the problem statement, there are 4 main issues, which are inefficient water usage, sustainability, inconsistent water distribution, and labor and energy intensive. In terms of inefficient water usage, traditional agriculture often lead to higher water consumption and uneven water distribution, and this result in deep percolation losses and nutrient leaching. So in our product design, we propose the system to use a sponge medium to efficiently hold and distribute the moisture, and this reduce the water wastage and ensure plants receive consistent hydration. Secondly, in terms of sustainability in agriculture is very crucial for reducing the environmental impact and conserving the resources. So by employing a sponge medium, this system minimizes the water runoff and evaporation. At the same time, it maintains the soil structure and optimizes the nutrient retention. And all these practices contribute to the sustainable water management and enhance the soil health. Thirdly, in terms of inconsistent water distribution, the uneven water distribution in traditional methods can cause soil degradation, increase operation costs, and affect the growth yield. So, the use of a sponge medium, it helps in maintaining uniform moisture level. At the same time, it promotes the balanced plant growth and reducing the risk of pest and disease outbreak. In terms of labor and energy intensive, as I mentioned before, traditional farming methods require extensive manual labor and energy consumption for irrigation, pest control, and soil management. So, integrating efficient water management techniques, it reduces the labor intensity and energy consumption and making the agriculture more sustainable and economically viable. So, in general, the adoption of the automated water treatment system using a sponge medium address the key challenge in traditional agriculture. So, by optimizing the water use, it enhances the sustainability, promoting uniform water distribution, and reducing the labor and energy demand. And this system offers a promising solution for modern farming practice.
Okay, so in our system, we are using relay, water sensor network, pump, solenoid valve, temperature sensor, resistor, capacitor, jumper wire, Arduino Uno, and also battery as our electrical component. And then for our body structure, we are using the cloth drying drum, rope, pipe, and also some rope, and all these things compound together that build up our whole system. So how actually our system runs is that firstly we will fill in the upper reservoir with the nutrients, then the nutrient will flow from the upper reservoir through a pipe to our plant at the upper level. Then the nutrients will drip from the upper level plant to the lower level plant, and in the end all the excessive nutrient will drip into the lower reservoir of the system. If the water level sensor at the upper reservoir senses that the water is not enough, then the pump will start working to pump the nutrients from the lower reservoir towards the upper reservoir. And in our system also, we integrated the temperature sensor so that when the weather is too hot, the solenoid valve will fully open so that it allows more water to flow in. And on the other side, when the weather is cold, the water didn't need so much water, So the solenoid valve will actually close and the irrigation of the water will become slower.
Now, every system have a pros and cons. So for our system, the advantage which is the pros, we can planting a more plant at one time. As we can see from the video, we can plant about a 6 plant at one time. And also for the system, we save space. Since the arrangement is vertically, it will save a lot of the space. And next is save the cost. For our material, most of the material we use is recycled item. So that's why the cost is quite low. It is also easy to handle. It does not require skill or anything. Everyone can handle the system. And lastly, it is an automatic planting. For the disadvantage of ours, first it cannot move easily. Since the upper reservoir is fixed at one place, it cannot move easily. And next is maintenance. It might be hard for the maintenance since the setup is quite complicated. So the maintenance is quite hard. Next is error. The error might affect the plant condition, which is the flow of the nutrient. Also, the cons is electrical component might expose to the water. And lastly is the nutrient. If the nutrient is polluted at the upper reservoir or at the lower reservoir, it might affect the ratio of the nutrient and it affect the plant.
So talking about the sustainability, we'll focus on 3 points. The first one is land efficiency, which is space optimization. The second one is the water efficiency. The third one is higher use. So talking about the space efficiency, where the hydroponics allow the vertical farming, which will reduce a lot of space, and it also will use less space compared to the traditional agriculture. So the second point is the water efficiency. So the hydroponics allow the water to circulate to the entire system, where it will use less water, less 90% of the water compared to the traditional farming. The third one is the higher use, where precisely control the pesticide and the water, so it will allow the plants to grow completely.
For energy sustainability wise, we actually use solar panel to charge our rechargeable battery via a charging module, so that we actually can use renewable energy to power our whole system.
Okay, so for our system, we are using 2 relays to control our actuator, which are the solenoid valve and also the pump. So for this water level sensor, it will sense the water level inside our upper reservoir, which is the blue color one. So as you can see here, we attached 2 water level sensor here, one up, one down. So when either one of the water sensor level detected the water, the pump will still not open yet because the water will be still enough. So the relay will still be off like this. But once both of the sensor didn't touch the water, the relay will be switched on and the pump will start working. And on the other hand, since our solenoid valve is always closed, always open, so the water will just flow continuously. That's why we attached a temperature sensor here. So the use of this temperature sensor is to close the valve when the weather is cold, since the plant didn't need so many water during the cold season.
This is a solenoid. This is a dripping system. So our solenoid is always open. So when the water is added to the system, the water will continuously drip to the plant. So here is the normal water flow for the plant. And for the bottom part, we will try to solder it so that it will have one hole from the bottom of it, and it will drip to the plant, the lower part. At the same thing, we also try to solder one of the hole to the plastic, and it will drip to the lower reservoir. So the water level in the water reservoir is getting higher, so we need to pump out the water to the upper reservoir. So here is the pumping process. This is the pump. So it pumps out to the upper reservoir. Now the relay is open, so solenoid valve will close it. So the flow rate of the water will become slow. The water level hits the maximum level and both of the water level sensors are submerged into the water, so the pump will stop working and the water will be dripping out to the solenoid to the plants. So to show the better understanding, we fasten the process by taking out the water manually. So when the water levels beneath the lower water level sensor, the pump will start to work. So now the water reservoir is lacking water, so we need to pump out the water by using the pump. So now we connect the power resources, then the pump is working. To fasten up, to show the better understanding, we need to manually add the water. Beside of the water reservoir, there has two water level sensor. Once the water touches the water level sensor, it will cut the current and it will stop pumping the water.
In conclusion, we can see hydroponics is a revolutionary agriculture technology that offers a sustainable and efficient alternative to traditional farming by using nutrient-rich water solution to promote faster plant growth, higher yield, and optimal resource utilization. This method enhances food security in urban and arid regions, reduce environmental impact, and ensure steady supply of fresh produce in a future with a growing population and limited arable land. Embracing hydroponic can lead to be a more resilient and sustainable food system for people and earth. That's all from us. Thank you.